Hi, it's Jan Beta, and today we are going to look into converting a conventional IBM PC standard floppy disk drive into a drive that works on Amigas and other retro machines. So the differences between PC standard disk drives that are actually, I think, still being made to this day and Amiga or MSX disk drives are not that significant actually. They use the same connector, which is this 34-pin IDC connector. They have the same power connector, which is a 12 volt and 5 volt power connector, 4-pin pin header here, and the mechanical parts are pretty much identical, except for these being high density disk drives, usually the PC ones, or at least the more modern PC ones, and the original Amiga disk drives are double density disk drives. But the HD disk drives are still able to read double density disks and write them just fine. So we're going to look into modifying these. So the main difference between these two types of drives is that the IBM PC disk drive standard was derived from the predecessor, which is the Shugart disk drive, and these are the drives used by some retro systems like the MSX and the Amiga, and the pinout is slightly changed and there are some other signals on the PC disk drives, but it is virtually the same. We just need to change some signals around basically to make the PC drive work in an Amiga. I have the pinouts printed out here. This is the Shugart drive pinout, the original one, and this is what became the PC standard, which literally just has a couple of pins changed around and a couple of extra signals. Let's go through these step by step and compare, I guess. So we have mostly the same pinout. This looks a bit taller because there is pin 3 marked, which is no pin in this position, which these drives actually have. Pin 3, there's no pin here. I don't know if you can see, but this is meant to be the key to put the connector in the correct orientation. And other than that, all the odd numbered pins are just ground pins, which is pretty interesting because they used a 34-pin connector where half of the pins is actually ground. So you could get away with a connector with a much smaller pin count, half of that basically, and just use one pin as the ground, but they decided to use these connectors and have a proper ground connection for half of the pins basically. That's also why most of the external drives have a much smaller pin count for these older systems than the internal pin count actually, because you don't need all the ground pins, you just need one proper ground connection basically. The signals are very much the same. We have the disk change on pin 2 for the Shugart drive, where the PC drive has a density select, which is obviously to detect if you are using an HD or a DD floppy disk. And these disks have a hole here. This is the write protect. And the HD disks have a hole here, which there is a sensor in the drive of some description. Most of the times it's just a switch that gets popped through this hole, and then this density select pin is going to tell the controller that it's an HD floppy disk. Other than that, the pinout is pretty much the same, except for, as I said, some motor enable extra signal on the PC drive. The Shugart drive only has one motor on signal and the PC drive has two motor enable signals, but these are not really used by the Shugart machines, so we can just neglect those. The only thing different is the disk change signal that is on pin 34 for the PC standard, and the disk change signal is on pin 2 for the Shugart drive. So we have to change pin 34 to have it connect to pin 2 on the connector actually. And we also have the ready signal on pin 34 where the PC drive has the disk change signal. That is basically a signal that tells the controller when the drive motor stops spinning, basically, and the drive is completely ready. This signal is not really used, at least by the Amiga, unless you use something like a sophisticated copier program, like Xcopy uses the ready signal to determine if the drive really is turned off and then starts the motor with the correct speed to make like good backup copies. As you probably know, if you ever owned an Amiga, you probably used Xcopy. And that actually uses the ready signal, and some other backup programs also used this signal. So we want to derive that from within the disk drive circuitry somewhere. Yeah, other than that, there is the drive select, which is also slightly different on PC drives. Usually PC drives are set up to drive select 1, whereas the Amiga and other retro computers need that to be set to drive select 0. This has device select and drive select. I think these are both the same. So DS0 is what we need. We need that signal on pin 10, basically, where the PC drive has a motor enable line, which we don't need for the Shugart standard usually. We're going to talk about drive select a bit more in a bit, but basically all you have to do to make a standard PC drive compatible with a Shugart disk drive system like the Amiga, we have to change the disk change signal to pin 2. And we need the ready signal on pin 34, which is not present on the regular pinout for the PC, but usually you can derive that from the controller chip. And even if you can't, most standard software is still going to load fine and work fine without that signal on the Amiga. And then we need to change the DS drive select or device select signal to a DS0, but only if you want to use the disk drive as an Amiga internal disk drive or in an external enclosure to replace an external drive that gave up the ghost maybe. And if you want to use it as an internal drive in one of the big box Amigas, you can just leave it as is, which is the DS1 setting usually for these PC drives. Your mileage may vary because some drives might be set up differently, especially if you get a used drive as I did. We're going to take a look at that. But that's basically all we have to do. So we just have to swap some signals around in theory, and we have a Shugart compatible drive. The density select is not really useful for the Amiga because that only uses double density disks. The regular Amigas, some later Amigas were able to use HD floppy disks, but they need some extra circuitry. So we're not going to be able to make a standard HD floppy disk drive into an Amiga HD disk drive without much more modification than I am willing to make. Let me take a couple of seconds to thank the sponsor for this video, which is PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication. They can populate your boards for you. Basically everything an electronics tinkerer needs, they offer on the website. The link is in the video description, and I highly recommend checking that out if you're interested in such things. Back to the disk drive. You might be inclined to ask why I'm doing this at all. The thing is that maybe you know, if you ever attempted to buy a used Commodore Amiga disk drive online on eBay or such platforms, you might have noticed that these are getting more and more expensive, and judging by my previous experiences with Amiga disk drives, they also become pretty unreliable over the years. They are mostly made in the late 80s or early 90s, so they are ancient at this point, and they are mechanical parts basically. Most of the times you can lubricate them and clean them and they start somewhat working again, but some of them are just lost. And replacing them is pretty expensive if you want a floppy disk drive in there. There's also the option, of course, to use a GoTech drive, which is an adapter kind of for using USB sticks, emulating a real disk drive. But one really nice option is to get very inexpensive used PC drives. I got these Mitsumi drives from eBay for €5 each. And in fact, you can easily pay 10 times that or about that for an Amiga drive, for a genuine Amiga drive. And modifying these shouldn't be that difficult. There's actually instructions online for a lot of these drive models. I think these are from the early 2000s, so they are about at least a decade younger than the Amiga drives. So without further ado, I'm going to look into these particular drives, which are Mitsumi model D359M3D drives that I got for €5. Two of them actually, in case I screw one up. And we're going to figure out how to modify these to be an internal Amiga 500 drive. It's actually the first time I do this, so I don't know if I am going to be able to pull this off, but it shouldn't be that difficult to swap some pins around and make this at least somewhat work. I actually just randomly bought these because they were inexpensive on eBay a while back. And as it turns out, these are actually drives that people already have converted to Amiga drives or Shugart drives. And there are some walkthroughs for these online, which makes things considerably easier. Sometimes you are going to have to figure out the pinout for the controller chips, which in this case I didn't find for this particular controller chips, but you might be able to scope the signals. The ready signals should be pretty visible, so you have to use your brain a bit, but there are walkthroughs for many existing PC drives from the 2000s to convert them without much effort. So I'm just going to attempt this for this drive. Your mileage may vary a bit. Some drives don't even provide a ready signal, but as I said, they can still be used in most use cases for replacing Amiga disk drives. If you want to use these internally in an Amiga, you may have to modify the whole plate here and modify the eject button a bit and things like that, which usually a bit of superglue or epoxy and some finessing is going to achieve. I'm not going to do this for this experiment because I just want to see if I can make this work with an Amiga basically. I don't even have a case for this Amiga board here I'm testing this on, so it doesn't really make sense to fit this as an internal drive at this point. It is a slightly different version than the one pictured in this guide here, I think, but it should be similar enough. So yeah, it looks slightly different. We're only looking at this small section here with the connector that is going into the IDC connector here, the pins on the circuit board. But the controller chip is the same that we have, and here are the wires that the person who did this walkthrough, TP, found this in the Amiga forum, which is one of the huge Amiga forums online. I'm also going to put links in the video description. There's also a translation into English of this particular walkthrough, so if you want to do the same thing on a similar drive, you're going to find links to the English and German version of the description in the video description, just in case you can't follow my video here. By the way, usually these are closed with 2 screws. I already opened this one to have a look at the circuit board and see which one it actually is. By the way, this pin numbering on this drive is super annoying because there's a 34 here and a 2 here, but in fact this is referencing the connector down here. So this is not pin 2 on the circuit board, this is actually pin 2, which you can also see by just following these. These are all ground, as I said, these are the odd pins. So this is pin 1, 2, 3, where there's the pin missing, 4, 5, 6, 7, 8, and so on. So the upper row of these are the even numbered pins and the lower row are the odd numbered pins, which are all ground. So first thing we need to do is to get our disk change signal, and in this case it's super easy because we just have to find a little solder jumper, DEN2, which is this one. I'm just going to zoom in a bit more, I guess. I hope you can see DEN2 here, or DEN2. We need to close this, and this seems to be already pre-configured to be modified, because this just puts our disk change signal to pin 2. And that should be everything we need to do in that regard. And then we just have to connect our ready signal. So we are going to close this with a blob of solder, I guess, which sometimes does work fine, sometimes it doesn't. If you don't get it done with a blob of solder, like me in this case, you can just use a little wire there or something. No, no dice. I'm just going to use the wire before I damage the circuit board. There we go. We made a connection and didn't damage any traces. So then 2, the jumper is closed now. Now we have to connect pin 34, which this is this one in the corner here. We need to connect that to the right pad of den 3, which is another solder jumper right next to den 2. And we need to cut the trace that leads to pin 34, because that would be our discharge signal, which we now have on pin 2 because we closed this jumper. You could, of course, also run a wire from pin 2 to pin 34. But we're doing it a bit more elegantly because somebody already measured where the signals go. And I'm using some magnet wire for the connection, I think, which is just enameled wire, which is insulated, stiff wire, which is ideal for these little modifications on circuit boards, in my opinion. So we need to cut the trace on here that goes to pin 34. And that should be relatively easy as well. Yeah, I'm just going to cut it relatively close to the pin here. Which sometimes is a bit tricky because you have to dig through the solder mask and things like that. And this is probably not the ideal place to cut this, but I think I made a nice clean cut there. So I cut this connection here close to pin 34, which is not this pin, but the top row here is what we're looking at. So let's see, from pin to this copper pad here. And we can also follow this to somewhere like here. There's no connection there. Yeah, that's our other side. We don't have any connection to the chip anymore, which is what we were after. Okay, and now we're going to connect this pin to the right pad on den 3 with a bit of this enamel wire here. I'm adding some fresh solder to our pin here and to den 3. You can heat up the end of this wire and the installation melts, which makes this relatively easy to use for these kinds of jobs. Just leave the soldering iron a bit on there and then we can make a nice little connection here and run it to our pin. Yeah, that should be a connection. Just double checking, so this is pin 34, that should go to here now, which it does, to den 3, right pin of den 3. And then we need to change the drive select. And for that we need to cut the trace that goes to pin 12 from the controller chip, or the other way around really, and connect the cut trace coming off the controller chip to pin 10. So we have this on drive select 0 as is used by the Amiga internal drives. If you want to use this as an internal secondary drive on a big box Amiga, you don't have to do this step because it is pre-configured, as many PC drives are, to DS1. So we need to cut the pin coming from pin 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this should be cut. I'm just going to cut it close to the pin again. And then remove the solder mask from this at some other position. And we need to connect that trace to pin 10. So this should no longer be connected to here. Which, yeah, that isn't connected. That's good. And we can follow this trace, I don't know if you can see this, this very small, to somewhere like here and remove some of the coating here to be able to solder on something. Just using my probe here to remove the solder mask and reveal the copper underneath. And then we can probably manage to solder onto that. We should be able to make some solder stick to that at this point. And then our wire. Yep, that looks good. And then connect it to pin 10, which is the right-hand one from pin 12, obviously. That's the difficult part, but that should give us the DS0. Which in this case, I think there's even a jumper for DS1, which we probably could have just lifted. There's a solder jumper closed somewhere here, yeah. But I'm just going by the instructions here, which is a safe bet, I guess, in this case, even if it's slightly different model of this circuit board, slightly different version. So this is by far the trickiest bit, but it should be perfectly doable. So I made like a 1mm scratch into the solder mask there to have some room to solder to, something for this to stick to, basically. Yep, that works. And now we have to connect this to pin 10, which is... Yep, that's connected on both ends. And it should be insulated against the other wire, so we don't run into any issues there. Let's see if this connection is okay. So pin 10 to here. Pin 12 is not connected to anything. Okay, so that should be all the modifications we have to do, technically. This is now configured to be a DF0 Amiga disk drive, in theory. Let's see what we get. So I'm just using the standard Amiga cable here, and this is keyed. The cable isn't, but it has a little notch there, or the connector has a notch, the cable has a little stud there. So we are going to connect this like so, and pin 1. So you want to make sure that you get pin 1, which usually is the red side of the cable, to pin 1 on the other end. In this case, we're going to have to connect this to pin 34, I think. So it should go like this, I hope. And the power connector, in this case, the older drives use 12 volts and 5 volts, and these slightly newer disk drives often have a 5 volt motor, so they don't need the 12 volts at all. I'm just going to use a USB power supply. This is one I made for my GoTech drives, but I don't have an Amiga power supply cable or disk drive power supply cable for an Amiga handy, so I'm just going to use this. And prop this up somehow. And yeah, in theory, we should have an Amiga drive now. So let's turn on the Amiga and see what the drive does. And the drive is ticking like an Amiga drive would, which is a very good sign. So it's probably at least halfway recognized by the system. Let's put a disk in. It sees the disk change. And we get the correct throw for Tarakin. So this seems to be a working drive. I just have to connect a mouse and a joystick and try again, because I forgot. So I'm just going to close this up again, connect a mouse and a joystick, and we're going to have a good Amiga drive, probably. This is literally clipped in and then secured with these two screws, so it's not that difficult. Now I can put this on here right side up even. I connected the mouse to skip the crack throw. I actually own the original version of Tarakin for the Amiga, so I think I'm fine piracy-wise there. Yeah, this seems to work absolutely no problems whatsoever. It seems to work just fine with the Amiga now. And that wasn't too hard. It took me, I don't think it took me longer than 15 minutes or so. And some research online about how this actually works. And it saved me like 45 euros or 40 euros or something. So yeah, to prove my point, that's running fine as an Amiga disk drive. Let's try Xcopy, I guess. So I fired up the 1992 version of Xcopy because that was the first thing I could grab. And I'm just going to pretend to do a DOS copy to the first drive because we only have one drive installed, and this should not start up at all without the ready signal as far as I know. So let's see. Yep, starts fine. And it reads everything good, which is also a good sign towards this drive being aligned properly. This is the German version actually. I think this is the actual version that I own the original disc of as well. So no piracy in this video. Oh, there's a check disc thing. Let's see. This is a very old disc. and a very cheap one. So if this shows me some bad content, that's probably because of the disk and not because of the drive. But so far, this seems to work pretty well as far as I can see. And this is a €5 used PC drive randomly bought on eBay. I think we made a viable Amiga disk drive from a €5 PC disk drive. And that's my old Xcopy Pro disk that I used back in the day, actually. Yeah, I am pretty happy with this result. Didn't take me long, just a bit of research. And I hope that you can modify your PC drives just like I modified this one to work on your older systems, and you get a good feeling of what it was like back in the day when we didn't have GoTex or like SD card devices to run software from. I love the sound of these. Admittedly, these PC drives, the newer ones, don't sound quite as clicky as the original Amiga drives often sounded, but still, it's a real disk drive. We can run all the regular Amiga disks with this. This should also format disks and things like that without any issues, and it's a way newer drive than what we would have originally in these Amigas. And the original drives, as I said, fail very frequently. Yeah, I think that's it for today. That's all I wanted to show you in this video. It is pretty easy and pretty convenient to have this in your repertoire, I guess. As I said, the first time I did this and I succeeded right away. Hope this inspires you to modify some old PC drives to be Amiga drives or for other systems or devices that need Shugart drives. Thank you very much for watching. Special thanks to everybody who supports me on Patreon and on Ko-fi and on the YouTube memberships page. Very much appreciated. If you want to give me some support, the links are in the video description. If you like this, don't forget to subscribe and click on the little thumb or leave a comment. I'm supposed to say that because I'm a YouTuber, as it turns out. Yeah, that's it for today. I'm Jan Beta. Thanks for watching. See you next time. Bye.